Hello everyone. Welcome to another session of live discussion. So today I again welcome Mr. Ashwini Kumar Sinha and Suresh Trivedi ji. Today our topic is Wi-Fi and Wi-Fi versus BLE. So today you can understand what technology suits you as per your needs. So my first question is, how do BLE and Wi-Fi compare in terms of energy efficiency for continuous data transmission?
Okay. So generally, BLE is designed for the very low power consumption devices and very low power consumption system. And most of the wearable devices that you see in the market use the BLE because of this, because they take very low power consumption, very low power. They can work in very microamps or milliamps power. So BLE, as per the name, you can directly guess about that. BLE, Bluetooth Low Energy. So it's a Bluetooth device that use very less amount of energy, very low amount of energy, and for the continuous transmission of data, where the data is not much large, but it's a small value like small sensor value, ambient sensor, or ambient light, or some few sensor value like health sensor, and all small amount of data that is not too big. Then using the BLE, data transmission rate is really good for those kind of things, and it's use very less amount of power. But when you compare with the Wi-Fi is designed to take give you good transmission rate, and also give you the greater bandwidth, the greater speed of transmission. And but at the same time, when you use the Wi-Fi, they usually takes a lots of power consumption in compare with the BLE. So if we see the data rate transmission for the BLE, then for the BLE, the data rate transmission is 2 Mbps maximum. That's the maximum for the Bluetooth 5.0. Below Bluetooth 5, if you go below that Bluetooth 5.0, then it is little bit more lower. And for the Wi-Fi, like if you are using the 3.5 gigahertz Wi-Fi, sorry, if you are using the 2.4 gigahertz or 5 gigahertz Wi-Fi, then it will gives you the 3.5 Gbps to the 9.6 Gbps, and even greater bandwidth for the for the Wi-Fi. So if you're transmitting the large amount of data, that's the size is little bit bigger, like in Gbps, in MB or in GB, then using the BLE for the faster rates and faster large amount of data is good for those kind of things. But if we talk about the power, then obviously Bluetooth is very low power consumption in compared to Wi-Fi, and it works in around milliamps to the microamps, and it's also gives you the better rate of transmission as well for the sensor value, where the data is not that big.
So, what is the maximum data rate achievable by BLE and Wi-Fi, and how do they impact the choice of technology for streaming applications?
Yeah. So data rates for the BLE maximum is 2 Mbps, and for the Wi-Fi the maximum rate ranges from the 3.5 Gbps to 9.6 Gbps. So one is the Mbps, another is the Gbps. So there is a huge difference between both of them. And so if you want to choose the device, which one is better for your design, then you have to see what kind of data, what is the size of the data that you are transmitting. It's not about the rate, because both can provide a good rate speed, but the size of the data is a bit it's important here. So if you are going to transmit the large file, if you are using the file transmission things, then BLE is a good Bluetooth is a sorry Bluetooth is a not good choice. Wi-Fi is the good choice. But if you are not transmitting the data that is in Gbps or something like that, you are just transmitting 1 MB of data or a small song or small sensor data and continuous sensor data transmission or song transmissions, audio streaming things, then BLE is always a good choice for that because they consume very less amount of energy and they can give you the good transmission rate as well without low latency. And in the few last year, BLE have also have launched the things, a few more technology like the Auracast. So let me tell you about the Auracast. What the Auracast is, that it can transmit, it can connect, one central device can connect to the multiple different device, and it can transmit all of them at a time, or transmit the audio at the same time. So here the latency is very low, and one music file can be transmitted to the multiple broadcasted. It's like broadcast station can be broadcasted to the multiple of devices that is connected between each other. So BLE 5.0 with the Auracast is really a good technology. So for the audio transmission kind of thing, for the earphones and all those things, or the smart watches things, or those or smart rings, the BLE is a good choice because they gives you the good transmission rate, and also they support the technology like the Auracast for the multi streaming at very low power consumption. But wherever if you choose the Wi-Fi, then it's the size. If it can transmit the GB size of data in a matter of seconds. So if the file size is large, then BLE choosing the BLE in your design is bad. It a bad decision.
How do the range and connectivity capabilities of BLE compare to Wi-Fi in both indoor and outdoor environments?
Actually, Bluetooth Low Energy and BLE and the Wi-Fi have different range and connectivity capabilities optimized for the distinct purposes. For example, its range. In case of BLE, indoor case, take a first indoor case. In this case, BLE typically offers a range of around 10 to 40 meters indoors. In case of, and depending on the obstructions like walls, ceiling, and the interference from the other devices. While we are talking about the outdoor, the VLE can achieve a range of up to 100 to 400 meters outdoor in ideal conditions with the fewer obstructions and the clear line of the sight. Now consider the range of the Wi-Fi. In this case, first consider the indoor. In this, Wi-Fi has a better indoor range, typically around 50 to 70 meters. For the standard 2.4 gigahertz network. But this can be very based on wall, furnitures, and the frequency band used. 5 gigahertz provides faster speed but the shorter range. Now, in case of the outdoor, Wi-Fi can extend up to the 100 to 200 meters outdoor, though some long-range Wi-Fi setup can achieve several kilometers with the specified equipment and the line of the site condition. Now come on the connectivity. First consider BLE. BLE is designed for the low power, short range communication. It's optimum for the IoT devices like wearable beacons and the sensors that don't require constant high-speed data transmission. And another is that BLE can maintain the low power connections over the extended periods, and its primary advantage is the ability to communicate with the nearby device while consuming minimum energy. Now, for the connectivity of the Wi-Fi is the better suited for the high bandwidth applications such as the video streaming, file transfer, and the connecting multiple devices. It provides faster data rate up to the several gigabits per second in the modern standard. Wi-Fi operates on a higher power compared to the BLE, making it more suitable for the devices with the lower power source or with the higher battery capacities. Now come on the differences. What are the key differences? In case of the Wi-Fi, its range is generally longer range, especially indoors. BLE excels in shorter range. In another point is the power consumption. BLE is far more energy efficient than the Wi-Fi, which is crucial for the battery powered devices. Now, speed. Wi-Fi offers much faster data transfer speed, while BLE is designed for the low power throughout the communication. In brief, you may say that the BLE is the ideal for the low power, short range application like wearable or sensor network, while the Wi-Fi extends its height throughout the medium range application like home networking or internet access, etc. That's all.
What are the security protocols supported by BLE and Wi-Fi, and how do they address, you know, vulnerabilities inherent to wireless communication?
Actually, both Bluetooth low energy and the Wi-Fi imply various security protocols to safeguard the data transmission and the address common wireless communication vulnerabilities like eavesdropping, unauthorized access, and the man in the middle MITM attacks. For example, first consider VLE security protocols. First is the LE secure connections. It introduced in Bluetooth 4.2. This protocol uses elliptical curve difference Hillman ECDH for the key exchange, which provides protection against the passive eavesdropping and the MITM attacks. Second, it offers different pairing modes, just works, pause key entry, and the numeric comparison with pause key entry and the numeric comparison offering more secure method. Another protocol is the AES-128 encryption. BLE uses AES-128 in CCM mode. CCM stands for the counter with the CBC MAC to ensure confidentially integrated key and the unauthorization of the data. This encryption helps protect against the data interception during the transmission. Third security protocol is the BLE privacy. BLE incorporate random access generation to prevent device tracking by rotating device address frequently. This reduces the risk of the tracking a device based on the MAC address. Another protocol is the security pairing. BLE device can pair using method of the out of band OOP and the passkey entry, which requires use intervention or additional channels enhancing protection from the MITM attacks. Now come on the security protocols of the Wi-Fi. First is the WPA2 Wi-Fi protocol SS2. In this, WAP2 uses AES-128 encryption with CCMP counter mode with the cipher block, chaining message, authentication code protocol to ensure the confidentiality and integrity. So this is the another parameter is that it uses in this address is like eavesdropping by encrypting data pockets between the device and the routers. Another is the protocol for the Wi-Fi is the web WPA3. It introduced to improve upon WAP2 to WA3 includes simultaneous authentication of the equal SAE, a more secure key exchange that protects against the brute force attack. Another is the in this three ensures that the past communication remains secure even if the current session key of the compromised. Another protocol in Wi-Fi is the 802.1x. This protocol is a commonly used in the enterprise network for user authentications, often in conjunction with the radius server. It ensures that the authenticized user can access the network, protecting against unauthorized access. And another protocol is a TLS oblique SSL encryption. Wi-Fi networks often rely on TLS, transparent layer security, for securing data exchanged between client and web servers, particularly for the application using HTTPS, providing an additional layer of the encryption. So these are the few protocols.
So, let me ask my next question. What are the cost implications of implementing BLE versus Wi-Fi in consumer devices in terms of hardware and maintenance?
Yeah. So the cost implication can be categorized in the three category. Like one is the hardware cost, another is the maintenance cost, and the third is the development cost. So let's first check at the hardware cost. So in if you go for the hardware side, the generally BLE chipset are little bit low cost, little cost you little bit low than the Wi-Fi. Like these kind of BLE chipsets from the various companies like the or Nordics or the ST Microtronics or NXP or many other Espressif or many other other companies. All those chips can see in the market in around $1 to $3. So the development cost, the hardware development cost, like the when you design a circuit using the BLE chips, and cost little bit a small lower because they you can get it around $1 to the $3 or maximum the $4. And if you compare that thing, the cost, the hardware cost, the chipset cost with the Wi-Fi, then it cost you little bit larger for the Wi-Fi because they often cost you around $3 to $10, or even larger, more larger cost. So BLE is a little bit cheaper than the Wi-Fi. BLE chipsets are a little bit cheaper than the Wi-Fi. And the second thing is the in the hardware side, you also need the power requirement. So generally, as we have already told you that BLE consumes very small amount of power. So the power requirement for the battery size cost, like you can run the BLE device on the coin cell or button cell, or you can maybe a small rechargeable repo batteries. They can run for the months or years, or according to the usage and transmission limit, and according to the to how the device is designed. But if you go for the Wi-Fi thing, then they need more power and they're more power hungry. So they might need the larger battery that cost you more on the battery side for the power requirement. You also might need the battery charging BMS module and many other IC integrated inside the device to maintain the battery or the power, or also need the voltage regulators for different kind of voltage regulation inside the circuit with the Wi-Fi. So this is the another cost that Wi-Fi increase on the design side. And then we just go on the development cost. So in the development cost, software development for the BLE is bit easy, but for the Wi-Fi case, some of the time it bit complex, because sometimes you have to make a web server kind of things, FTP things, and many HTTPS protocols and many things where you need to code and do a lots of things. But while the BLE, it's easy, and a lots of tools are there already that using which you can transmit the data and design your firmware. So, and then the third point is the maintenance cost. So maintenance cost, I've already told you that BLE use very low amount of power. So maintenance for the BLE are automatically little bit easy, and it's cost less than the Wi-Fi, because when you use the BLE device, it can run for years or for months using the coin cell or using the lipo battery, and the charging discharging cycle, because it takes low cost, because it take low current, low power. It's not that much power hungry. So charging and discharging cycle of the battery is very less in the BLE side. So as the charging and discharging cycle of the battery lessen, then the uh, lifetime of that battery get increased. So you might need to change the battery for after many uses, many years of usage in the BLE device. But in the case of Wi-Fi, as we have already told you that Wi-Fi is power hungry. So battery get charged and discharged very quickly because they consumes more power. So the life cycle of the battery, the charge cycle of battery get decreases very fast, and they got the battery on with the Wi-Fi devices got degraded very fast, and might need you maintenance for the battery, and might need to change the battery after the 1 year or several use. So these are the three category on which you can divide the cost, and then you can select the device, select the technology that you want to implement in your design.
Okay, so for which type of applications BLE is more suitable than Wi-Fi and vice versa?
Yeah. So for the application where I've already told you earlier that application where the data transmission rate is not needed that much, and the size of the data is not that much high, like it is around 1 MB, or it is within the 1 KB, like a small sensor value data, health sensor, and all those sensors. So those kind of design BLE is a really good choice. Or for the audio streaming, like I've already told you that last year the BLE 5.0 have one more function that is called Auracast. So one single device can connect with all each other and can transmit and broadcast the music to the multiple of device, stream the multiple of device without any latency, and at the same time. So this is amazing technology for the audio transmission. Like you have one Bluetooth device here in my room, one Bluetooth device in somewhere else in the another room, one Bluetooth device in the kitchen, and all those devices are connecting over the BLE, and music is streamed to all the device, and you can control the music streaming or of individual devices using the BLE. So this is the amazing technology. So for the audio transmission, and for the smaller sensor data transmission, for the wearable device where you need the very large where you need the very good amount of battery life, and very good amount of charge cycle, then BLE is a good choice in which compared to the Wi-Fi, because BLE can works in very microamps to milliamps power, and it can give you the decent amount of transmission speed as well, and it also costs you low in compared to the Wi-Fi.
So how do BLE and Wi-Fi handle interference from other devices operating on the similar frequency? You know?
Actually, both Bluetooth and Wi-Fi operates on a 2.4 gigahertz ISM band, making them susceptible to interference from each other and the other devices using similar frequencies. However, both technologies imply various strategies to mitigate interference and the coexist effectively. Now, first consider the Bluetooth BLE. First, in this case, frequency hopping spread spectrum FHSS. BLE uses adaptive frequency hopping to reduce interference. It divides the 2.4 gigahertz band into 40 channels, 2 megahertz wide each, and rapidly hops between these channels up to the 1600 times per second. By doing this, BLE reduces the likelihood of the staying on the channels that is the experiencing interference. Another is adaptive frequency hopping, AFH. The AFH is and the enhancing to have the frequency hopping. BLE can detect channels that are congested are experiencing interference and they avoid them, hoping only to the cleaner channels. This is especially useful for the coexisting with Wi-Fi, which uses a different channel structure. Another is the low duty cycle. BLE is designed to be low power technology and with the short burst transmission. Since BLE devices transmit data only whenever necessary and for short periods, the chances of the interference are reduced simply because BLE device spend to a lot of time of interactive. Now come on the Wi-Fi. Wi-Fi carrier sensor multiple access with the collision avoidance CSMA RCA. Wi-Fi uses this CSMSA RCA to avoid the collision. So before transmitting the data, Wi-Fi devices listen to the channel to check it if it is already in use. If the channel is free, the device transmits. If not free, then it does not transmit that. It waits for the random period before trying again. This reduces the interference, especially with the other Wi-Fi network and the devices on the same channel. Another is a channelization. Wi-Fi splits in 2.4 gigahertz band into the 11 or even more, depending on the region channels that are 20 megahertz wide. However, only three channels, 1, 6, and 11, do not overlap. By using non-overlapping channels, Wi-Fi network can reduce interference. Devices and the access point can switch to the less channels in the interference is detected. Another is case of Wi-Fi, another is the dynamic frequency selection, DFS. In the 5 gigahertz and some region in the 2.4 gigahertz band, Wi-Fi can employ DFS to detect radar signals, even switch to different channels when necessary, which helps to avoid the interference. Another is the coexistence strategies between the BLE and the Wi-Fi. First is the time division multiple, TDM, time division multiplexing. Some devices, especially those that use both BLE and the Wi-Fi, implement the time division multiplexing to ensure the Wi-Fi and the BLE are not transmitting at the same time, avoiding the collision. Another is the interference detection and the avoidance. In case of BLE and the Wi-Fi, devices can detect interference and they either switch channel or back off transmission until the interference is subsidized. Another is the hardware level solution. Many modern chips are designed with the BLE and Wi-Fi coexistence in the mind using technologies such as interference cancellations, shared antennas, and the intelligent scheduling to minimize the conflicts. And the last one is the physical separation and antenna devising is also very important. In this, another strategy to coexistence the physical separation of the antenna used for Wi-Fi and the BLE. This reduces the likelihood to interfere at the hardware level. The specialized antenna design can also help optimize signal transmission for the each protocols. That's all.
So, what is the latency characteristic of BLE and Wi-Fi, and how do they affect the performance in real-time applications?
Yeah. So in terms of latency characteristic for if you compare the BLE technology and the Wi-Fi technology, then for the BLE size, if you can't get everything in a one chip or one technology. So everything comes with some kind of advantage and some kind of disadvantage. So if the BLE give you the advantage of low power consumption and also give you a decent speed, then latency, then it might be there are some areas that which it lacks, and here is the part where the BLE lacks in compared to the Wi-Fi. So BLE latency generally lies within the if you talk about the BLE 4.0 and the 4.1, then it generally lies between the 30 to 100 milliseconds. And if we talk about the BLE 5.0, then it is get reduced little bit. And I hope in the future, if this technology get more advanced and we get some kind of more data compression system inside that thing, then it will become more useful. BLE, let's talk about that. Then BLE 5.0. So BLE 5.0 latency rate is 15 to around 50 milliseconds. So if you compare this with the Wi-Fi, then Wi-Fi latency rate is very low. If we talk about the 802.11n, that is the Wi-Fi 4, that what we call the Wi-Fi 4, then its latency rate is around 20 milliseconds. And if we talk about the Wi-Fi 5, that is the 802.11 AC, then its latency rate lies very small, that is 5 to 10 milliamps. Sorry, microseconds. 5 to 10 microseconds. And if we talk about the Wi-Fi 6, that is what 802.11 AX, its latency rate is around only 1 milliseconds. So if your system needs to transmit the video, so transmit the large file, or if your system is about transmitting and sharing the file data and all those things, then the Wi-Fi is a good choice because its latency is late. If you are transmitting the video, then it need to be the real time, then you need to use the Wi-Fi because latency is very rate. But BLE here in this kind of application, the BLE suffers a lot. So if you use this kind of file sharing, the video transmitter, video streaming things and use the BLE technology for these things, then you face a lots of lag in between the data transmission. So like suppose that I have connected the Wi-Fi camera with here in the laptop, so it's real time, it's the real time. You can't figure out any lag in the video transmission and between the what I'm speaking and what I can see in the screen. So it's very small lag. It's all because of the Wi-Fi technology. If we use the same thing, if we implement the same thing, so if we want to implement the same technology with the BLE, then it's a lots of lag. And when I speak and when I move the hand, then it's a lot of delay between my hand and the what transmitted there to the laptop. So for the BLE, its latency is really large, that lies between the 30 to 100 millisecond, and for the Wi-Fi, it's around 20 to 1 millisecond.
So, How do BLE and Wi-Fi manage power consumption in devices that require long battery life?
Yeah. So BLE, generally, if you design the devices like BLE, then external, external kind of, power systems didn't require that much. But if you want to add, then you can add, because BLE consumes very small amount of power, and you can, if you want to add, then you can add the BMS module for the battery charging and discharging, but it's not really that much needed, but so some people have, and some, in most of the device you can see that, and I also see the voltage regulators out there in the thing. But for the Wi-Fi, it's very necessary thing to manage the power consumption and all those things. And for the both technology, it gives you the one of the function using which you can manage the power usage on the device that you are designing. So for the BLE thing, it gives you the system, or gives you the option to sleep, deep sleep, light sleep system, where it can go to the device, the main chip can go to the sleep, and then it can wake up, and then start transmitting the data, and then go to the sleep again. So this is how these chips can manage the powers and make it more power efficient using the sleep function. And Wi-Fi chips also give you this function to go to sleep and deep sleep as well, but it compared to the BLE, it consumes a lot of power even while it is in sleep. And second thing, most of the time we use the Wi-Fi for transmitting the and sharing the file, and sleeping mode is not that much efficient for, and that not that much needed in this kind of application, because while transmitting the video, why you need to keep the chips in sleep mode, why you need to keep the Wi-Fi off. But why in most of the BLE module, it gives the option to sleep. Like you might have used the smartwatch, or might have used the BLE remotes, and might have used the BLE mouse, or might have used the BLE earphones. So you have noticed that after viewing the time or getting the notification on the watch, after a few seconds, that watch screen turns off, and you might feel that this is not working. That is in the sleep mode. That their whole device in sleep mode to save the power. That is the one of the function that it BLE provides. And like if you are using the earphone, so when that earphone says that it got disconnected and you are no more listening to the music, then it's got in the sleep mode to save the power. And whenever you restart the music, when you replay the music, then it automatically get a start, and start streaming the things and get connected with each other. So that is a sleep mode that it really provides to you, and it saves the power of overall system.
So, how do the complexities of integrating BLE and Wi-Fi into a devices differ, and what are the implications for product design and development cycles?
The complexities of the integrating BLE and the Wi-Fi into device differ significantly due to their underlying architecture, power requirement, and intended use cases, which ultimately affects the product design and the development timelines. For example, in case of the BLE, power it is designed for the low power energy efficient applications which make it the ideal for the device like wearable sensors and battery operated devices. When integrating BLE, designers focus on the optimizing power management using smaller batteries and the ensuring extended battery life. This low power characteristic simplifies certain aspects of the hardware design but require careful attention to the power optimization. While in case of the Wi-Fi, on the other hand, consumes significantly more power, making it more suitable for the device with the larger power budgets, like smart home device or the industrial equipment. Wi-Fi requires more complex power management circuits, longer antenna, and the more sophisticated process units, which increases the design complexity. While while we are discussing for the communication range of the data requirement, to first in case of the BLE, it is typically used for the short range, low bandwidth. communication. This leads the simplified network architecture as the integrating focus on the point to point on the mesh network design, often reducing complexity and the cost of for the developers. PLE mesh networking capabilities makes it well suited for the application like smart lighting or the sensor network. While we are talking about the communication range for the Wi-Fi, so it is a high bandwidth technology. It supports more data intensity application and provide internet access over the longer range. So this is the however, design of the Wi-Fi requires more atta- attention to signal strength, antenna placement, and the uh, uh, data throughout, especially when the handling multiple devices in an IoT environment. This increases both the complexity of the software stack and the amount of the testing needed to ensure reliable performance. And the third complexity is the for the software stack and the protocols. In case of BLE, it is a simpler to implement with the fewer layers in the communication stack and the standardized profiles for the specific use cases such as the heart rate monitor, beacon. This simplicity often reduces the time requirement for the software development and the testing. While in case of the Wi-Fi, in contrast, it comes with the complex networking protocols, for example, TCP, IP, security layers, and the advanced features like quality of server, QoS. The software stack for the Wi-Fi is more intricate and demands more time for debugging and ensuring compliances with the network standard networks. So this is the complexity of the software of the both. And third is the security consideration. It is also very important parameter is the security consideration. While consider first Wi-Fi, Wi-Fi generally requires more robust security measures such as Web3 encryption and the authentication protocol, adding the complexity during the development phases, especially for the IoT devices that are exposed to the internet. While in case of BLE has simpler security protocols like AES encryption, which are the sufficient for the most short range low data devices. But many requires additional layers if being integrated into the security crucial. Another parameter which is very important to consider is the cost and time to market. BLE integration is generally more cost effective due to the lower hardware and the software complexity. It allows for the faster product integrations and the quicker time to the market. While in case of the, especially it in industries like wearable and the consumer electronics. While in case of the Wi-Fi, while providing the getter functionality, it increase both the bill of material, BOM, and the development cost, as well as they extend the time to market due to added complexity in testing and the certification. So these are the complexities of the both.
So how do the characteristics of BLE and Wi-Fi influence the user experience, particularly in terms of connection speed, time, reliability, and speed?
Okay. So let's talk about first the connection and the setup thing. So for the BLE thing, for the BLE technology, the user experience, you might have already experienced it. I am just elaborating it out. So if you are using the BLE device, the smartphone and remote with the TV or the earphone with your phone, smartphone, you already have experienced it. And what I am telling you can relate with my words that, yeah, it is really right. So let's talk about the BLE. So for the BLE, the user experience for the connectivity side is really easy because these devices, once you pair these devices, it can connect with each other very fast. Like TV remote, and every time when you turn on the TV and use the remote, BLE remote, you don't need, you need to repair and connect and all those stuffs. It will get automatically paired, connect and wake up and start working. If you are using a smartphone with your connected with your connected with your smartwatch, then you have also experienced that the connection is really very simple. When you turn on the smartphone, that automatically get connected with the phone. Once it's just one time pair. You just need to one time pair for that, and it is not that difficult. It get easily paired with each other, and then they can both transfer the data, and they can sense that that other device got disconnected, another device in sleep, and they can re-wake up or reopen, repower, and then reconnect with each other. It's very really simple, seamless, and you already have experience with your earphones, earbuds, the smartphones, and the TV remotes. So connection side, the user experience is really smoother for the BLE thing, but for the Wi-Fi, this case is not that. This is really just opposite of the Wi-Fi. So you might have seen when you were connecting to a Wi-Fi network, or when you were connecting to any kind of Wi-Fi devices with the phone, you have to set the SSID, then you have to set the password. Even if the SSID, if you have not insert the password, then you have to select that Wi-Fi network, that SSID of the Wi-Fi network that you want to connect. And when you tap on that, then you can see there obtaining IP address, connecting, and connecting, connection failed, something like this. So a lot of complexity is through the user side if you see for the Wi-Fi technology, because it takes a lot of things in between to work with and to pair with each other and to transfer with each other. They need to authenticate with each other. They have to pass security layers for each other. So for the connection side, the connectivity setup, the BLE is really smooth for the user experience side. And let's talk about the reliability. So for the shorter range, BLE is really reliable. It can transmit the data without much, without much latency, and it can give you the good, and it can easily be paired with each other, and they can transmit for the short range of data. But for the longer range, the BLE suffers. So if you have the smartwatch, and or if you're using the earbud with your phone connected with your smartphone, and if you go far from the smartphone, then both of them get disconnected. So BLE suffers in this kind of reliability when the distance is large. But for the shorter distance, they are very reliable, and they are very smooth, and pretty good experience from the user side. But for the Wi-Fi, they are good for the long range. Even if you have the smartphone on the if you have some project, if you have Wi-Fi camera and the ground floor, and want to check the thing from the top floor of the floor, and if both are in the Wi-Fi range, then they can transmit without any latency, and they can both connect it easily, and they will provide you good range and good reliability as well. So for the Wi-Fi, range is good, and user experience for the range side, Wi-Fi is really good, and for the connectivity side, BLE is smoother compared with the Wi-Fi. And let's talk about the speed. So in the BLE side, BLE gives you the decent speed for the low amount of data that I already told you. And for the Wi-Fi side, it is really high speed data, and you can transfer and share the stream the video, audio files, and share the file it between the devices at very high speed. So for the Wi-Fi, it's very reliable for the larger file size and connectivity, and the range.
So my last question for the session. With evolving technology standards, how can design engineers future-proof devices that utilize BLE and Wi-Fi? And what consideration should be taken for software update and hardware stability?
Yeah, that's a really nice question. So for the Wi-Fi side, your device can be connected using the Wi-Fi. Your device can be connected to the internet, generally Wi-Fi is used for this purpose. So you can connect the device to the internet and to the cloud. So once you have connected the device with the internet and cloud, then updating the firmware and the device is really, easy and really smooth and super easy. So suppose that suppose that if you are using the if you are using the Wi-Fi for the firmware update, or if you want to do the software update on the Wi-Fi based device, then you can connect the device with the internet using the Wi-Fi, and from anywhere in the world you can send the software update to the device using a technology called OTA, over to air technology, using which you can transfer the data and you can do the software update over to air. Might have seen the notification on your laptop or your phone that new software update is available. So how this is done? This is all done by the software OTA technology, over to air technology. They transmit the new software to your device using the OTA, and the device can download that software from the server or the cloud, and then install it on your device. So for the Wi-Fi, it is really a smooth, and it is really easy, and it can be manageable from the anywhere in the world if both the devices user and the service provider are connected over the internet. But for the BLE, it's bit difficult. BLE also support the over to air things, like you can transmit and give the update to the BLE devices over to air, and transmit the firmware from one device to another device wirelessly. But the range is short, and it is not connected to the Wi-Fi. It is not connected to the internet. So you have to be within the range of the transmitter device that is going to do the software update, and that is going to get the software update. So generally, what most of the times you might have seen with your smartwatch and the phone, that those service provider what to it use the phone internet like Wi-Fi or the cellular network to give you the software update on the application on which BLE device is using or connecting, and then that smartphone then transfer that data, that software update firmware to your device. So it's the multiple connection in between. But if you are not using the cellular network or Wi-Fi connectivity or any kind of internet Ethernet connectivity, then we have to be within the range to give the firmware update, and its range is very really short.
That was very insightful. I hope the live discussion was helpful for many of you. If you have any query, you can post it in the comment section. We'll get back to you in the next discussion. Thank you.